Okay, so welcome to the lightning talk session, and we have a few slots lined up, and Rudolph will start with his talk about virtualization with Ganeti. Good luck. Yeah, sorry, I need to open your slides. Who is everything?
Okay. Hello, everyone. Thanks. Welcome to my talk about virtualization with Ganeti. A few words about myself. I work for Zipgate, so this is my day job. My night job is working or hacking on Ganeti, and sometimes it mixes because we're also using Ganeti heavily at Zipgate to support around 700 virtual machines. And let's see, who of you knows Ganeti or has heard of it? Well, fair enough. So just a quick recap, what is Ganeti? It's a virtual machine cluster management tool. It scales between 1 or tens of nodes, or maybe even hundreds of nodes. You can actually run a single node cluster if that suits your needs, but you can also, of course, have it run with tens or hundreds of nodes. The number of instances or guests is usually only limited by your physical resources, so there's no real hard limit on that. And everything you need is available with a standard Debian installation. That's probably important, as opposed to other solutions where you sometimes need extra sources, external sources, or more complicated setup ways of setup. This actually just works out of the box. Some thoughts about the features. It allows for automatic instance placement and cluster balancing, so you don't have to worry about where an instance runs. Ganeti can take care of that on its own. It allows for live migrations, but it depends on the hypervisor and the storage you chose. If it's KVM or Xen, for example, can make use of emulated devices or VirtIO devices. It also has a so-called OS provider interface. So it allows you to actually pre-seed or bootstrap your instances with whatever way you prefer. Actually, Debian currently ships with two types of OS providers. One is called NoOp, which actually does nothing. It can be used to, for example, use existing Pixie boot infrastructure to set up virtual machines. Or you can use the so-called debootstrap OS provider, which just uses debootstrap to provide you with whatever debootstrap is able to set up. So, for example, Debian-based or Ubuntu-based instances. But you can also pretty much easily write your own OS provider, which, for example, uses images to prepare, for example, Windows-based instances if you have a need for that. You can manage it mostly through a CLI, which is available on the master node, but you can also use a REST API if that suits your needs better. A word about the hypervisors supported, and I put this in quotes because probably not all of those might qualify as a hypervisor. The current first-class citizen is probably KVM in a fully and semi-virtualized mode, so fully as in you do a classic BIOS boot and have a full disk image, and semi-virtualized would be using, for example, a kernel and an init RAM disk which resides on the host. Xen works in AVM, or HVM, or PVM mode, but isn't as well tested probably currently, although it's the hypervisor that Ganeti was initially built with. There's also LXC available, but it's also not very well tested, or maybe not tested at all. And there's also something called the change rule provider, which I only found out by accident that it exists at all. I don't know much about that. How's data stored? There's a very easy mode. It's called the file mode. It's local only, so you can't have, for example, live migration. There's a slight slightly different mode, which is called shared file, which is just a file mode, but Ganeti assumes that your folder locally, which stores the images, is magically available to all nodes, for example, if you use NFS or something more sophisticated. So it actually can use, for example, live migration, because it knows the files or images can be accessed from all nodes. There's also LVM, which is also local only. It's internally named the plain mode. There's DRBD, where actually Ganeti automatically sets up a DRBD mirror per instance. So whenever you have an instance spawned on one node, it will have a backup on one other node. And this will give you a giant mesh of DRBDs in the end, but you never see that. It's all handled by Ganeti, and you can always fail over an instance between the two nodes. There's also a native support for Ceph and one for Gluster, but I don't think Gluster has been used in a while, so that's probably might even be broken. It's rather unmaintained, and there's also support for external storage providers where you can pretty much use anything for storage. There's also, as far as I know, there's a Ceph implementation using external storage providers, which has some improvements over the built-in support. Mostly used is actually shared file or DRBD. We're using DRBD at Zipgate, for example. Networking is rather standard. You can use standard Linux bridges with VLAN aware or VLAN unaware bridges. You can use a routed mode or open vSwitch, whatever suits your workload or whatever you can implement in your network easily. And a few parts about the background. Originally, it has been developed and open sourced by Google around 2007. So they use it heavily on their internal network, not for production workloads like YouTube or the Google search engine, but rather for internal stuff, branch offices, etc. It used to be GPL version 2, but it has been relicensed to too-close BSD in 2014, and a while after that it has actually been kind of abandoned by Google because they had no use to extend it any further. It was finished in a sort of sense. It since then has been transferred actually to a community. All assets has been transferred to SBI Inc., which is probably known to most of you. There has been one major release since the takeover of the community, which is the release of 3.0 or 3.01 by now, which was mostly the migration from Python 2 to 3, because most of the Ganeti code base is Python. The other part is Haskell. And as you all know, Python 2 is nearing, or actually has passed its lifetime, so that was an important step to take. So actually it's quite future-proof by now, but there's lots of work to do, and we're still looking for more contributors, reviewers, and users. It actually it's quite heavily used in some parts. For example, universities, Tor project, Wikimedia, Debian uses it, as far as I know, on internal systems. Lots of universities and also commercial companies, for example, like Zipgate or Spreadshirt and others. So there's quite some usage, and I think it kind of fills a gap. If you need to use OpenStack, it's probably nothing you would build for running 50 or 10 VMs. And if you're somewhere between 5 and 500 VMs, you're probably fine with Ganeti because it scales well, it's set up easily, and as I said, it just works out of the box on a stock Debian system.
Last minute.
This is like a very small quick start. All you need to do is install a few packages if you want to use KVM and Ganeti, initialize a cluster, add more nodes if you need to, add an instance, and you're done. So it's actually quite easy to get up and running with that. Being it on a single node or if it's a 3-node cluster or whatever. So the only thing you should probably avoid is a 2-node cluster for obvious clustering reasons, but 1 node or 3, 5,000, or let's say 100 shouldn't be a problem at all. That's it. Thank you.
Okay, thank you for your talk. and Vasu will be next. So let's Gardener, right?
Yeah.
Let's set you up with the microphone
Thank you.
and take it away.
Okay. What?
You have 5 minutes.
Oh, I've got 5 minutes. Oh, I thought I was... No, 10 minutes.
10 minutes.
Negotiated.
Yep.
Yeah, all right. Press F5. Okay, I didn't hear that.
You
All
have
right.
10 minutes.
Thank you. My name is Vasu, and I got volunteered by my colleagues here to give you a short talk about what the heck is Gardener, right? So while I will be talking about the technical side of things, about, it's a Kubernetes as a service management tool, and it thrives on its technical inception design. Yeah, I'll be talking about that. There's actually another hidden story here organizationally, because Gardener within a large enterprise like SAP is an underground project. It's a grassroots project. I like this potatoes of defiance because that's exactly how it got initiated. And today the team thrives on its enthusiasm with open source, right? And there's no attachment to any commercial thing. So if you go to gardener.cloud, the homepage, what you get is the management tool. You get a multi-cluster operational UI, and then you can go ahead and create Kubernetes clusters on any type of infrastructure. You see all the logos here, and we've got a long tail of community members which actually contribute extensions to our project. Yeah. So remember, with our enterprisiness, our goal is, we need to manage potentially 100,000s of Kubernetes clusters. You see that thing on the right-hand side here. Something with the control plane, something with the worker plane, and we need to manage day 1, day 2, upgrades, downgrades, and so on. And we obviously need to control the stack, so that's why we're so much interested in the Debian as an operating system. That's where the Gardenlet talk came from. And so let me talk about how Gardener is implemented. So if you think about it, what's the definition of Kubernetes? Kubernetes, I won't read it out, it's good for managing containerized software, right? And if you then think a second iteration, Kubernetes itself is software that is delivered in containers. So what we do essentially is we use Kubernetes to host and operate Kubernetes. And that's the inception or kubeception design. So the next slide typically is animated, but in a PDF it's just flattened out. So think about the shoot clusters, that's how we call it, the botanical naming came about. That's the end user cluster, and it needs to have a control plane. And instead of putting that control plane next to the worker plane, we actually host that control plane in that other Kubernetes cluster here in the middle, which is called the seed cluster, and there we create essentially a namespace and drag and drop that control plane number A onto that. So now the interesting part is that seed cluster is another Kubernetes cluster, so we can actually do control plane as a service. We can scale, right? And we can not only scale across one seed cluster, we can actually put these seed cluster all over the world and have a central management API. That's the thing on the left-hand side. That's the central management API cluster. What Kubernetes actually gives us in addition is the following, and I've kind of depicted that in the lower half of the middle cluster. You can see that the control plane needs to manage machines, and it might need something like a cluster autoscaler. All of these things are also containerized services, and we elevated everything we need from the infrastructure into Kubernetes controllers. So if the control plane needs another machine, it just orders one in the Kubernetes style, declarative. And we also, that's the other thing, the HVPA symbol over there, that's a horizontal vertical pod autoscaler. So if the control plane is hit with lots of demand, we can actually scale horizontally, add another API server horizontally, And if that doesn't suffice, we can actually scale it vertically, give it more CPU on that container, or give it more memory, right? And add, obviously, custom services. And we do this, as mentioned, on all of these infrastructures that we, on the enterprise, need. So it has very high quality, but also we are open for extensions like the Hetzner's and OVH and so on, right? So typically, on this laptop, I can't give you a live demo, so I've done a couple of screenshots. And it looks like this. So this is the Stack IT. That's the Lidl or Schwarz Gruppe in Germany. They're using Gardener for their infrastructure internally. But we also have small and medium businesses like bnerd, a small hoster in Hamburg. They're using our Gardener infrastructure. And this is how our development system actually looks. So you can see the development here. There are multiple clusters across various infrastructures like OpenStack, VMware, Azure, GCP. I think Ali Cloud is not in this screenshot. We have various versions, and the symbol next to that icon actually tells you, yeah, you can upgrade that, and it does that live, right? And we can hibernate. You see that ZZZ over there, and you get a nice status. We also have a web terminal, and what's interesting is you can actually, with this web terminal, log into the 3 different clusters we're having. So the one on the right-hand side, the central garden cluster, then you can log in to your cluster itself, of course, but also in the seed cluster, which hosts the control plane. And it basically looks like this. We're built in Kubernetes. We are a first-class citizen of Kubernetes, so you can actually argue about all of these elements with Kubernetes methodology. So here you can see I put in a command, said kube control get the shoot, called bnerd number 3, and you can see it's hosted on OpenStack, it's reconciled, and so on. So that I can do directly with the web terminal, but I can then also go into the control plane cluster, the seed cluster, and you can see here the various containerized elements of a control plane. Like down there, you can see the vertical pod autoscaler recommender, and you can see the etcds and so on. If you're knowledgeable about Kubernetes, this actually gives you exactly the insight, and you'll know what I'm talking about. And with respect to the end user, you can see here that we automatically have a cluster autoscaler and built in, and you can choose various types of worker pools with different types of operating systems. So in this one, you can see on the upper half, there's a worker node with Garden Linux and another worker pools, worker groups, as depicted here, one with Garden Linux and one with Ubuntu. And you can scale them, and you can tell I would like to have gvisor in it, and so on. So it's all fully configurable, right? And so in the end, we, as I hopefully was able to convey to you, we can create clusters like sliced bread, but there's more. Yeah? So the question is this thing difficult to learn, right? 1 minute I have, very quickly. Is it difficult to learn? So if you learn Kubernetes, you will learn that there's a Kubernetes API server and that there are kubelets. And if you want to schedule a pod, there are 2 additional controllers, the kube scheduler and the cloud controller manager and so on. And the pod gets scheduled to a kubelet, and then the needful is done by the node number 1 in this case. The architecture for Gardener is exactly the same. So if you learned Kubernetes, you have learned Gardener. So we have a Gardener API server and a Gardenlet that is basically managing the seed. Yeah? And if you ask for a cluster, there's actually a garden scheduler and a controller manager that schedules your cluster onto an available seed. And that's the end. Thank you.
Thank you very much. So, next talk is Lea.
Thank you, Toby. So, hi everyone. I'm talking a topic a bit away from operating systems. I'm talking about building synthetic training data, and it's in the context of machine learning with the simulation environment AirSim, which is built on top of the game engine Unreal Engine. So, to give you a little bit of context, I worked at the German Aerospace Center last semester, and the project I worked for was Drones for Good. The idea behind Drones for Good is to use machine learning to help with humanitarian help and in catastrophic failures, like this year in the Altai, for example, where humans can't get through, but where help is still needed. So we wanted to use drones to fly packages with goods like water or food into those zones. And to make it as safe as possible, we want to use human detection, so the packages are, the drones throw the packages at places where it's safe to throw them and no one is harmed. So to use this, we use obviously machine learning, and machine learning needs a lot of data to be trained. So we found out that we need a lot of data with a huge diversity. So we have a diversity of the environments and of course of the humans, a diversity in daytime and at the night, for example, and weather. And the more diverse the data set is, the better. And what we have currently are 3 data sets, and those 3 data sets lack some diversity. So we could use those and hope, it's okay, and try not to improve it. Or we could use some real data that we make, so we get our drones and fly out, and took some humans with us to make those data sets. But this is pretty, this costs a lot, and it's easier if we use a simulation environment. So the idea is to use synthetic data to build this training data. And so we used AirSim for that. This is a free simulation environment, open source, works also with Linux, built on top of the Unreal Engine. And we created some environments because we can use all environments which are available for the Unreal Engine. So everything used for games can be used for our worlds we use to place humans in. And here you can see a park environment on the left side. And on the right side we have a segmentation picture. Everything is black, but the humans are white, so we can use those pictures to train our neural net. We can choose different angles of the drone flying above the humans and place a lot of humans. We can place non-humans. We can all configure that and use it in an automatically way. So we can ensure our diversity and configure all those parameters. And the idea is basically to train a neural network. In this case, we used YOLO V4, which is a pre-trained network, and we fine-tuned it with the res, with our pictures, and this is an example of the results. So we find some humans in real data sets, but there is still room for improvement. And if someone wants to talk about synthetic data and detecting humans, please use the rest of the conference and the tear down and talk to me if you want.
Thank you.
Thank you, Lea. So, Bastian.
Ich brauche noch deine Slides. Bitteschön.
Hello, everyone, and thanks for having me. In this talk, I want to tell a little bit about our migration of our Freifunk wireless network to WireGuard. First, some facts and numbers about our network. We host it on an infrastructure of roughly 14 Debian hosts that are deployed to 2 physical machines. We have an interconnection of 2 times 10 gigabit in Frankfurt to accommodate for all the traffic, and roughly 400 nodes online. On average, we have 700 to 900 users and 7,000 daily clients, as well as roughly 30 terabytes of forwarded traffic every month. So the problem, we use Freifunk-Gluon, which is used by most of the communities in Germany, and it runs on tiny hardware. The most used VPN daemon is called FastD. It is a single-threaded user space daemon using a questionable crypto and has very limited performance. So to solve the problem, there are different approaches that were run in the past, but since WireGuard got more popular in the community, we have chosen that approach because it's fast, it's simple to configure, and it makes use of multiple CPU cores on the more recent hardware that has multi-core CPUs. In addition to that, it runs in the kernel space versus user space, so it gives you some significant performance advantages. The main challenges, since FastD is quite promiscuous and accepts any connection with any public key, WireGuard is different here. It expects, or it needs to know the public key of each peer that wants to connect. So we needed to create something to make the gateways aware of those peer keys. So our community has developed a daemon for it. It's called WGS-Kex, and it's available on GitHub. So basically, the node, when is booting, it transmits its public key to our gateways, and then the VPN connection can take place. The integration on the node side, on the Freifunk router, was not existent, so we had to integrate some stuff in the community packages, and so to make the node or the small piece of hardware aware of WireGuard, so it could work. Then we were not sure if we have a performance penalty because we added an additional layer in our VPN connection. So currently we are running Batman over VXLAN over WireGuard compared to 2 layers we had in the FastD approach, which was only WireGuard on FastD. But it turned out to be relatively good. On the gateway side, it was a little bit difficult to accommodate the network stack for working with this approach, with this layered approach. So the IF up-down package was not ready yet, so some manual tinkering had to be done. Meanwhile, this is fixed. The results. Currently, the Freifunk nodes, or let's talk about the performance increase. The very smallest router we have in our network, the very tiny, ultra cheap ones, TP-Link 841, now nearly doubled or more than doubled the performance from 8 to 22 megabits. The more recent multi-core Fritzbox 4040, which is also very cheap, makes 100 megabit meanwhile. And an average Freifunk router, let's talk about the TP-Link 4300, increased to 40 megabit. So this is all an improvement on more than the double scale, which is pretty surprising. So we also got a better burst behavior. So when we have small traffic bursts, WireGuard works way better than FastD did. And so, we had a nice performance increase by factor 2 to 4, depending on the hardware and CPU count, despite adding an additional layer. So, thanks.
There's even time for one question.
What Debian are running on the WireGuard hosts? As in, I think you need kernel at least 410 or something like this because of the kernel extensions, right?
I'm not aware. I think it's 410, yeah, right?
Sorry, 510.
510, you're right. It's in our Git. I don't.
So that means bullseye, right?
You mean on
or
the gateway
did you
side?
do a backport?
Gateway side, it's bullseye, right?
Okay, got it.
Yeah.
And the exactly if you go back one slide, the routers, they run some sort of leader or OpenWRT.
It's OpenWRT-based, Freifunk-tailored distribution.
You still do your own images, right? That hasn't changed.
Pardon?
You still do your own images. That hasn't changed.
Yeah.
Okay, thank you.
So, you're ready for the next talk then?
Looking to the schedule, Benno.
All right. Hi, my name is Benno, and the cryptic name of my talk, Voros M, a little bit longer, is about the formal verification of real-time operating systems using a model-based approach of quantification, runtime quantification. I'm studying here in my Master of Applied Science, and this is the topic of my project, of my research project. So what's the motivation for this project? Over the last years, established software is utilized during growing variety of hardware. So the need of standard software and the reliance of it is increasing. And in certain circumstances and environments, there is also the need of some real-time critical requirements, and therefore there is a need for some approach to get the reliance or reliable statements about the runtime behavior. And formal verification is not new to the Linux kernel, or is not a new approach in general. And therefore there are some existing approaches, like from Daniel de Oliveira, was just publishing some preparing stuff for my project, and I am extending this approach in a few ways. The main idea is, first of all, to trace. There are many ways of doing it. First of all, we are thinking about using an internal, the internal infrastructure and mechanisms to get the tracing data, but also we are going to use some hardware debugger to use external tracing. Then we are generating some models from it. And the models that are generated are finite state machines in the first line. And these state machines are extended with some transition latency on the translations. So we will add the information about the latence between some state shifts. And with the help of some statistics and probability distributions between the subsequential states, we will prepare for some reliable statements about the runtime behavior of some system. And this is just at the beginning. However, there are going to be first measurement results very soon. The first results are about using the Linux kernel. But there are a few further interests that I already mentioned a little bit. First of all, what is the influence of the measurement itself? So the point of internal and external debugger, and the the quantification of it. What is really the influence of it? And second, what is the behavior? What is the trade-off between the duration of the measurement and the quality of the deriving statement? And I mentioned already we are currently using the Linux kernel, but there are a variety of combinations that will be looked at. First of all, we will have some different architectures like ARM, PowerPC, RISC-V, and so on. And besides the Linux kernel, we will also have a look at the Barrelfish kernel, and maybe, if there is some time left, about hypervisors. Yeah. So that's my project in a nutshell. Have you time? Okay. Are there any questions?
Any question? So, any questions?
So how do you ensure that you covered all relevant code paths for the tracing?
Sorry?
So how do you ensure that you covered all relevant code paths for the runtime behavior when doing tracing? I mean, you derive a model from that, and that's possibly as good as your traces.
We are... so this one, we have two approaches of generating a model. First of all, this is tracing based. This will be the second approach. First of all, we have some models from the Oliveira that had another goal in mind, and he had developed a theoretical model of the scheduling subsystem of Linux, and this model was not derived by the tracing, but it was another approach, and with this approach he actually found some bugs in the code that should not be there, and this will the first approach using the Linux kernel, and then with some extensions of the architectures and other kernels, this will be a first step using the tracing data.
The answer is using expert knowledge, and that means you, Jan.
Okay, so Benno, thank you very much. Now we have Michael with a live demo, so we momentarily switch laptops.
Hey. Okay, does anybody else want to give a lightning talk? Then I'll make it very quick. Otherwise, I'll try to keep it at 5 to 10 minutes, and then Nick will lead us out. Okay, so I'm going to do a live demo. Let's see how that goes. I force pushed half an hour ago. Probably will go badly, but let's see. So I want to talk about, where is it? Running auto package tests on porter boxes. So why do I want to do that? Sometimes we're getting bug reports like this one. So I'm doing scientific software, and then somebody says, well, your scientific software, it fails on ARM64. And nobody bought me an ARM64 yet, so basically the only way to actually debug auto package test failures would be on the Debian porter boxes. So Debian has this nice developer machine things, and there are a couple of porter boxes. And in this case, for ARM64, it would be amdal debian.org. And you can log in there, and you can even, there's change roots there, and this is all very fine. Now I realize that I should have a better micro. bit too big, maybe. Yeah, don't worry. It's okay. So this is an ARM64 machine, as you can see, and it has this really nice DDS change root command helper, where you can create change roots there, or you can create change root sessions for unstable, for all the other possible Debian distributions like testing, and there's loads of them. And what you also can do is you can install stuff in there. So you can run apt-get in there, but that's about it. And I found it difficult to run auto-package tests in them. And maybe somebody else knows exactly how that works, and I'm just too stupid. So what I did is I wrote a short shell script which figures out which packages you need to install in the change root first, and then run auto-package tests in it. Wow, that's very nice of you. It's called... Oh, it's on Salsa in my personal archive, and it's called DD Auto Package Test. And it's really just a very stupid shell script. And you can download it and make it. And then you can, for example, let's say, I guess the package hello will probably have an auto package test, right? Because it's the demo package. So what this does is, it will untar the change root. That's what S change root does there, or there's the change root helper does. And then afterwards, it will install. First, it will try to update it, and then we'll install auto package tests and some core packages, and then all the dependencies it finds by running auto package tests and figuring out what's missing, installing that, and then running auto package test itself. So that should be done in a minute. Now it's installing auto package test. So basically you just run DD auto package test and the source package name. And if you want, you can also tell it which distribution, but it runs on unstable by default. Now it tries to figure out the test dependencies. I think there's probably none. And then it's running auto package test, and does it work? No tests in this package, unbelievable. Wait. Okay, let's have a look. Hello. BTS contains patches fixing 2 bugs. You could consider this. So include a trivially auto package test for this trivial package. And there's a patch by somebody called Michael Banck. Because the other one was bit rotten, so I had to fix it up. So what you can do then is you have to actually de-get it or something, because there's no source URLs in the stable main root of those. That's a bit of a shame. You have to unpack the source. Then you have to get the patch. I hope that's probably going to not work. Right, so here we are. Now there's Debian tests control. And now we can run DD stable again, but this time in the root, or in this thing, and it will just copy over the source and then run auto package tests from there. And while it's running, any question? Does anybody have a better idea? How are you doing it? Is nobody ever had to run auto package tests on a Porter box? Who had to run auto package tests on a Porter box? Who's a DD who could theoretically do it? Oh, Nicola, yeah.
So while the test is running, we can already prepare for the next talk.
Any questions or comments? No. Okay, then let's see. It's running. Let's hope that it's working. It's again updating, unfortunately, because those change routes are not updated every day. And usually on these porter boxes, it can take quite a long time to get all these packages installed. So maybe it does something else now in the test dependencies. Yes, it's installing Hello itself. And now it's running auto package test, and it passed.
Yeah. Yeah.
Here we go. I'm sorry, it's not double screen now.
Okay. Dominik?
So I have to remember my own slides, right? Okay, so I want to give a short update on the Debian Edu Pure Blend, or someone told me recently there's a new name for Pure Blend. No, I don't remember. How do you do this?
Okay, let's debug that.
Okay, so what is Debian Edu? Debian Edu is a pure blend. It is a set of packages. Firstly, there are some meta packages that collect educational software that is available in Debian for different types of schools or for different subjects. And the second part is a set of configuration packages that turn a Debian installation into a machine usable in a school network. It has several profiles, one being a central server for management of user data, computers, computer labs, groups, classes, or stuff like that. And that does all the central network services like DHCP and DNS and file serving and everything you would expect from a network server in a multi-user system. The second and probably most important profile being an LTSP, Linux Terminal Server project server that allows net booting computer labs and the devices in the school network. And on them it provides a full-featured desktop with all these educational packages pre-installed and configured to use the central authentication system and file server and everything set up completely. This has existed for a long time. Some might already know it under the word Skole Linux, which today is just another name for the same thing. And yeah, now I need my slides. Huh?
Where is...
Aha. Thank you, system administrator. Okay. No.
You broke it. What's...
Okay, I will try to continue without the slides.
Okay, that is not good. Somehow crashed.
Tom, can you quickly pass me my laptop, please? Thank you.
Yeah. Wo ist er?
HDMI?
Yep.
Linke Seite.
Yeah, that talks, lightning talks are always an experience.
I have no idea how to make this go full screen, but no. F5 actually reloads.
F11.
Huh. I don't care. So the main server has one issue. It is built to be a robust network server for an enterprise-grade local area network. And as such, it is tailored to the use in a computer lab in a school. But the recent years have taught us that education has to be decentralized and turned into asynchronous and decentral formats, and it can benefit from such formats even if we are not in a pandemic. And with all these enterprise-grade networking components like LDAP and Kerberos authentication, it is hard to decentralize this system. If you have people working at home, or if you want to place some applications in the cloud, especially web applications, then you need to make sure to make the Kerberos authentication work and the Kerberos server reachable over some VPN connection, or work with secure TLS tunnels, or whatever you want to do. And this is not really something that a school administrator wants to do, or someone operating such services for schools wants to do. So what we are working on now is trying to turn Debian Edu in a system that moves more towards the web, because mostly all modern applications used in education are websites, web applications, and we need free open web services for students, and they need to use their single sign-on accounts they get from their school. They also need to use these for the other platforms they use, not only when they are sitting in the computer lab in the school. And we also need a modern management app, because the Goza front end that is used in Debian Edu is a bit dated, and it's not really tailored to the use cases of teachers. They don't really want to use it. It is one point where schools say, oh, we are not choosing Debian Edu, we are choosing Linux Muster, for example, because they have a more or less beautiful web front end for doing the management, and that's what matters for the teachers. So what we want to do first is replace this management application with Alexis, which is a school management platform, free and open source. And it is modern, it is mobile friendly, it also has features for information management in a school, like timetables in this screenshot. So what we want to do is we want to turn Alexis into a backend for the Debian Edu system, and we want to make the Debian Edu system use Alexis for management. One component we probably will be using for this is the NSS Palm Web API module, which I created, and I for learning Rust mainly, to allow a system to consume a web API and an OpenID authentication backend in Palm, so you can authenticate to the system using a web platform, which is cool because you can use both Alexis, the school management system, for your single sign-on accounts. But if you already have Microsoft accounts in your school, because some politician told you need to, then you can also log into your Debian desktops in school with your Microsoft accounts, because it's just another OpenID provider. One benefit from this is also that we can fix the NSS privacy issue, because normally when you run get and passwd on any system, you get a full list of all users, including their full names, or you can turn this list off, which somehow makes me cry as a Unix system administrator. And when you just put this in front of a web API, then you can let the web API handle authorization and just serve you the people that are in your same class. So you can, if you teach people Linux in the computer lab, you can have them change own and change mod files to share them with others, and it still works. But they don't need to get the full user list to make it work. The rough roadmap is we want to package Alexis for Debian, which is mostly finished during MiniDebConf Regensburg. Thanks, Tom, for handling so many Python packages by now. And then we want to slowly migrate from the LDAP Kerberos system to the web API system, and then turn the main server profile into something that installs Alexis and configures it as a backend for the rest of Debian Edu. Once we're done with that, I hope that we can start introducing more profiles so that you can also install Moodle, Nextcloud, or some applications that matter to your school directly from the Debian Edu install and from the Debian Edu system. Will this be Debian Edu? I don't know yet. I proposed it to the rest of the Debian Edu developers. There was quite good consensus that we want to try this. We will be working in experimental and see how it turns out for the bookworm release. If it works out and everyone likes it, then yes, probably this can get the new Debian Edu and become a really modern and cloud-friendly backend and desktop solution for schools. If you want to help, package some Python modules. We're mostly finished with it. There's still some JavaScript packages open for grabs. It's a boring task, but if you like it, please ping me. Thanks for listening. I think we can handle one question. There was the last lightning talk, right? No more question?
No more questions.
No more question. Okay. Thank you.
So, thank you very much.